This is a 2020 AMC 8. So we start from number 11 as always we do. After school, Maya and Naomi headed to the beach 6 miles away. So this is like 6 miles from zero to like in 10 minutes. Naomi arrived in 10 minutes. And Maya arrived in 30 minutes. Okay. So this is their journeys, the time and distance traveled. Difference in miles per hour between Naomi's and Maya's average speed. Okay. So this is miles per hour. But now we have data with miles per minute. So Naomi, 6 miles per minute, 10 minutes. 10 minutes is 1/6 hours. So this is 36 mph. And Maya, 6 miles in 30 minutes. So hour. So this is 12 mph. So the difference is 24. Number 12, the positive integer and factorial notation. Okay. So now we have 9 here. 1, 2, 3, 4, 5, and 9 factorial. So 9 factorial means from 9 to 1, like descending, like these consecutive integers. We multiply them all together. So now we take it out, the 12, and now we have 1 and 2 and 5. So 1 and 2 and 5 times 9 factorial is 12 times 10 times 9 factorial. So 9 factorial is from 9, 8, 7, blah, 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 until 1. And now we have another 10. So all together, this is 10 factorial. Number 13. Jamal has a drawer containing 6 green socks, 18 purple socks, 12 orange socks. More purple socks, okay, 18 plus P, let's say. Notice there is now a 60% chance that socks randomly selected from the drawer is purple. So all socks now, 18 plus P plus 12. Now we have purple, 18 plus P. This is 60%, 160. So now, let me make it even simpler, 3/5. So 36, 18 plus P over 36 plus P, 3 to 5. So 90 plus 5P equals 108 plus 3P. So 2P becomes 18. P is 9. Number 14. 20 cities in the county of Newton. The population shown by chart below. Average population is indicated horizontal dashed line. Okay, so all 20 cities. So actually we need to understand what is the meaning of average. So average means when we have different numbers of data, different values of data. Like for example, when we have 2, 3, 4, and we are saying the numbers are 3, like average is 3. It means actually it has the same value. Of course, the meaning is different, but same value, like a total value. And even we consider all of them are 3, like a 3, 3, 3. So this one 9, and this also 9. So 1, 2, 3, 4, 5. We have average 3. So we can say all number. Let's say all number as a 3. Then this is 15 and this is 15. So which means this is 5,000, 4,500, 4,700, 4,750 maybe. And now we have cities, 12 cities. So this means if we consider all the numbers, population is 4,750, still this is the same amount of like total amount. So 4,750 times 20, 9, 0, 0, 0, 5, something like this. Number 15. suppose 15% of x equals to 20% of y, so 3x becomes 4y. What percentage of x is y? So from here we can say y equals 3 over 4x. 3 over 4 is 75% because this is 75 over 100. So 75% of x is y. Each of a point A, B, C, D, E, F, different digit from 1 to 6. We don't know what is 1 and what is 6. 5 sums. So the first sum, let's say S1, S2, S3, S4, S5. No, actually, L1. Let's call S1 is the sum of the numbers on the first line, which is A, B, C. S2, F and B. S3, C, D, E. S4, A, E, F. S5, B plus D. So when we add them all together, it's 47. So 2A and B, 3B. Yeah, makes sense. 2 and 3, 1, 2, 3 lines. C also 2, D2, E2, F2. So when we add them all together, it's 47. So you know, here, 2, A, B, C, D, E, F. And we have another B, it's 47. But the numbers from A to F is from 1 to 6, which is 1, 2, 6, 1, 2, 3, 4, 5, 6. Oh, no, I mean 6. 7, 7, 7, 21. So this is a 21. So 42 plus B equals 47. So B is a 5. Actually, we can tell what is B only. We cannot tell what is the other numbers. Number 17, how many factors of 2020 have more than 3 factors? We can take them out, these prime factors, which has only 2 factors, and 1. So 2020, 20 times 101, and 2 to the power of 2 times 5. 101, can we make any I don't think so. So 2 to the power of 2, 5, and 101. You know, I will tell you the number of how to find the number of factors. Here, when we make it like this, find this decomposition of the prime factoring by prime factorizing, then we can find this number 2 and 1, which is the count of this prime numbers. So when we add them all together like 1, so 2 plus 1 times 1 plus 1 times 1 plus 1. This is the number of factors. So 3, 2, 2, 12. So there are altogether 12 factors of 2020. But there, out of 12, we need to subtract 1, 2, 5, and 101, because those are prime factors which has only 2 factors, and 1 has only 1 factors. So here more than 3 factors. More than 3 factors. I didn't know that. So anyway, let's take out 4 first. So now we have, we can start from 8. So we can remove 9 and 10. So more than 3 factors. Anyway, we can compose it like these factors. Like let's say 1 over 2, 1 over 5, and 1 over 1 over 1, 2, 5, 2, 1 over 1, 5, 1 over 1. Can we make anything else? 2, yeah, again, 2 to the power of 2, 5 to the power of 1, 1 over 1, 1, 1, 2, 3, 4, 5. Because this is 1, 1, 1, which means 2, 2, 2. It has 8 factors. This is 3 times 2, 6 factors. 3 times 2, 6 factors. Yeah, there is more. So this is 2 and 2, 4 factors. We can find 2 times 5. It also has 4 factors, and 2 times 1 over 1. It also has 2 factors. So 1, 2, 3, 4, 5, 6, 7. I think so. Right? Because if we have only 2 to the power of 2, this is 3. So we cannot have. So now we have 7. Number 18. Rectangle ABCD inscribed in semicircle with diameter FE. So area of ABCD. Okay. So here, this is the radius of 9, 8. So we can find the BA, 9 squared, A squared, 81, 64, 7, root 17. Oh, isn't it? 7, root 17. Oh, but why there is no? No, I made a mistake. I said that the radius was 9, but radius was not 9. Radius is, all of this is radius. So 8 and 9, radius is 17. So 17 times 8. So this is 17 plus 8, 17 minus 8, 25, 9, 15. So this is 15. So 15 times 16, okay, 240. The number is called Flippy. The digit alternate between 2 distinctive digits, like 2020, 37373 are Flippy. 3883. Okay. Okay, how many 5-digit Flippy numbers are divisible by 15? Divisible by 15 means divisible by 5 and 3. Divisible by 5 means the last digit should be 0 or 5. Divisible by 3 means the sum of the digits should be divisible by 3. So for example, if we make 0, so last number cannot be 0 because if it is 0, the first number should be 0 too. So we cannot make any 5-digit Flippy numbers who has last digit with 0. So last digit should be 5, 5, 5. So now we have 15 already, which is divisible by 3. And let's make it. So 3 and 3, 6 and 6, 9 and 9, and 0 and 0, like this. So only this, those are divisible by 15 and 15, which is divisible by 5 and divisible by 3. So okay, 1, 2, 3, 4. Number 20. Scientists walking through a forest record an integer, the height of 5 trees standing in a row. tall, either twice as tall or half as tall as the 1, 2, it's right. Okay, so if we have 1, let's say this can be 22 or 5.5, for example, like this. So we don't know. So her note shown below, the blank indicates the missing numbers based on her observation. Average height of the trees in meters. Okay. So 1, 2, 3, 4, 5, and we have here 11. So here 5.5 or 22, let's say. But because this is the smallest average height among the options, and when we 111, which means if I make it here 5.5, I need another 5.5 because I need to make the last digit like without any decimal, for example. But here, for example, here 11 and 22, I cannot make any like 111 number, for example, because we need to make it more than, I mean, we don't know more than, but anyway, at least 111, all of the same. So I guess there is no 5.5. So here, 12, 22, 11, 22. So all of here already 55. So now we need to go further. So let's say if I go here 11 and 22, let's say, then 33. So we cannot make it again. So which means I need to make here 44 and 88, let's say. Then here, let's make 186, but 88 is it very tall? So anyway, so it means here, until here, this is very clear. This should be 44. So now we have 99. So last three can be 22 or 88. Let's say if it is 22, then 121 divided by 5, 24.2. Okay, and let's say 99 plus 88, 17, 187, and divide by 5, this is 37.2. So this cannot be. So we have only 24.2. Oh, so this is the board of the game, 64 squares. And we have P and Q. A step consists of moving the marker into one of the edges adjoining white squares in the row above. How many 7 steps path there? P to Q. So P to Q. So we can go. Adjoining means maybe here or here, for example. So let's see. So actually from P to Q, we need to eventually make 1 to the right. Eventually make 1 to the right. So here, right, left, left, right, right, left. So right, left, left, right, right, left, right. So eventually we made 1 right, like this. So what I'm saying, so right, 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 left, 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 but we have another right, then eventually we will reach to Q. But we can arrange, all of them. We need to arrange them how to arrive to Q. So for example, but the problem is, this is not like fully operating. We have only 2 vertical lines there. So this is a little bit risky. That, because I think this is the farthest we can go, for example. So if we have here, let's say, this is the farthest we can go, you know? So we can consider all the cases and just remove the case we need to landing here. So let's do that. So anyway, we need to arrange it 4R and 3L. So when we have this consecutive, the same letters in the arrangement, there is a very easy way to find the number of arrangement. So anyway, those are all 7 characters. So we make 7 factorial, like arrangement of 7. But in this case, the 3L is considered as the different L's, like L1, L2, L3. So L1, L2, L3, L1, L3, L2, L2, L3, L1, all of them is considered as different cases. But we know those are not different in our case. So we need to make them all like the same case, like one case. So simply we can divide by 3 factorial for L and divide by 4 factorial for R. So 7, 3, 4. So let's canceling them out and we have 35. So all these cases, we have 35 different ways to reach from P to Q, but we need to, but still we also consider to landing here too. Like 1, 2, 3, 4, 5, 6, 7. Oh, quite a lot. So when we pass by those 3 squares, which we cannot go, is like 7 different cases. So out of 35, we need to subtract the 7. So the final answer is 28. Number 22. Positive integer n fed into machine. Output is number calculated according to rule. So n is even, then half. Out times 3 plus 1. Okay. So like this. 5 more times. So when the same 6-step process applied to different starting value of n, final output is 1. What is the sum of all such integers n? So, okay, n, blah, 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 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So this is 1. So let's go like reverse. So out of here, oops. If this is the previous one number was 2, then because of divide by 2, then it becomes 1. And like even or odd, can it be 0? Positive number, so it cannot be 0. So actually, the last digit can be only 2. But if the previous one was even, then it can be 4. And this cannot be Yeah. So 3n plus 1 cannot be 2 with positive n. So, okay. So until here, 4 and 2 is fixed. There's no more other cases. But here, now it can be even or odd. So it can be 8 or 1. So if it was 8 and even odd, then 16 or it cannot be. And if it was 1, 2, and cannot be. So 16, 32, or 5. So 2, again, 2 cannot be other number, it can be only 4. So from 32, so from 8, so from 32, this is for the last one, 64 or no, 5, 10 or no, from 4, again 8 or 1. So now we have the case of n, 64 or 10 or 8 or 1. So we have 4 different cases. Sum. So 74 plus 9, which is 83. 5 different awards are be given to 3 students. Each student will receive at least 1 award. How many ways can the award be distributed? Okay. A, B, C, D, E. And now let's call those students' name P, Q, R. Then we need to make a PQR, assign PQR. Any of here and another like 2 more positions. Let's say P, Q, R and P, P, for example. This can be possible. So I think just now from the previous question, I explained you how to arrange when we have the same letters in the arrangement. So for example, we can arrange PQR and PQ or QR or RP, for example, or PQR and PP, QQ, RR, for example. So in this case, we arrange 5 factorial and over 2 factorial and 2 factorial because P are 2, Q are 2. And we have these 3 cases plus 5 factorial over 3 factorial. And we also have 3 cases. So 5 factorial times 3 over 4, 1 over 2, 4, 5, 5, 4, 3, 2, 1. 150. Number 24. Large square region is paved with n squared gray square tiles, S inches on a side. So the number is n. Here also n. It looks like a 3, but and now in this case, gray tiles cover 64% of the area of the largest square region. What is the ratio D and S? Border is D inches. Here D. So large side is so now we have side S times n. And 1, 2, 3, 4, D as n plus 1. When we have 3 squares here, we have this pathway, 4 pathways, for example. So this is the side, and yeah, and the small one It's just as it says. So the large area is the square root. S plus n, S times n plus d times n plus 1 squared. So small one, s squared times n. So s squared times n over Sn plus d n plus 1 squared was 6. This is the ratio of the total area, like a gray area to total area. So now let's, when n equals to 3 times s squared, 3s plus 4d squares becomes 0 point, no, n was 24. So 24s squared over 24s plus 25d squared was 64%, 64 over 100. So let's make it simplify. So 75s squared becomes 2, 24s plus 25d squared. Okay, so now we are almost there. So 75s squared becomes 2 times 24 times 24. D over S. Something, did I make it properly? The area, 64% of area of the largest square region. So the largest square region S times N. And we have 1, 2, 3, 4. N plus 1D, so 25D. 24 S squared. Yeah, I think I did well. So 75s squared is 2, 24s plus 25d. So now, you know, because of the calculation, that's why I'm hesitating to go further. So let's make it a little bit simpler. So now, anyway, we want to know d over s. So let's make the factoring on the right side with s. 24 plus 25d over s squared. So 25s, no, I mean, not 25. 75s squared becomes e2 s squared, 24 plus 25 d over s squared. So it's not n squared. So this was not 24, because I couldn't like, I need to go through this third form. That's why I could not convince. So now n squared. So 24 squared. Okay, now I think it's getting better. So 64, 100. So 64, I think this is 9. 8 times 8, this is 8 times 3, n squared, so 9. So now 900 s squared is 24. S, let me make it s, 24 plus 25 d over s squared. Oh, no, I mean squared. I mean squared. Then 30s, both of them, like we can make a square root. S 24 plus 25 d over s, s. So 6 becomes 25 d over s, 6 over 25. Number 25, rectangle R1, R2, blah, blah, blah. Side lengths of S2. Okay. So combining to form a rectangle, 3, 3, 2, 2, units wide. Sorry. So here 3, 3, 2, 2. Here 20, 20 high. So what is the side length of S2 in unit? So all squares. So x, x, y, y, z, z. So R1. So x plus y plus z becomes 3, 3, 2, 2. X plus z minus y becomes 20, 20. Because this is z minus y. Okay, so now we want to know what is y. So let's subtract them together. So this is 2y. 1, 3, 0, 2. Y 651. That's it.